All right, so we're going to be doing homework 9, number 4 here. It's kind of a long one, so stick with me. So essentially, we have a thin film type question where there's alcohol on top of a glass plate, both of which are provided index of refractions for. Monochromatic light, which wavelength can be changed, is incident on the film. The reflected light has a maximum when lambda equals 756 nanometers and a minimum when lambda equals 432 nanometers. And we're going to have to determine the minimum thickness. So in this question, we're basically given scenarios in which it's like constructive and destructive, right? So we set up our equations for those. Just going to be, starting with the destructive. I apologize. I'm going to have to keep looking back here, and I'm going to put my face in the camera just because I can't see so well. But so yeah, I'm going to be starting with the destructive here. I'm going to say, so it's going to be 2D equals M, and then just lambda. But we have to remember it's lambda of the substance, right? So I'm going to put it over N alcohol, right? Actually, before I get started, I think it'd be better to define every single variable, just so we're clear here. So in this question, here I'm actually going to pause my recording so I can take a picture of my notes so I don't have to keep turning around. All right. So as we're just going to define every single variable here. So what we have is the index of refraction of alcohol. I'm going to call that my N1, right? Because I know it's going to go through the alcohol before hitting the glass plate or whatever it was. And then I'm going to have the what I'm going to call N2, which is just the glass, and that's given as 1.51, right? We're also told that the max wavelength is at, so I'm going to call it lambda max, is at 756 nanometers. So, and then my lambda minimum is at 432, right? And essentially what we're solving for is that distance d between them. So in this situation, like I said, we have two scenarios of destructive and constructive. So if we set up our equations for both, we'll see that we have 2d, this is with respect to destructive, equals m max, lambda max, right? And the other important thing to remember here is we're given these wavelengths in air, so we actually have to recognize what they're going through, which itself is that alcohol. So I'm going to put it over N1, and that's per the property, right? That like lambda substance equals Y in the air. So lambda in the air divided by the index of refraction of the substance. So that's how I know to do that. But I'm going to assume that we're all on the same page in that regard. So we'll leave that like that. And then the other equation we're working with is like the constructive here. So we're going to see that 2D equals the order minimum plus 1/2. And then y lambda min divided by N1 for the same reasons that we already discussed. Sorry, my laptop charger is right underneath there and I almost tripped on it. So the next thing, if you have a good eye, is like we can set these equal to each other, right? Because they're both equal to 2D. So what we can do is set M max, lambda max over N1, and that's going to be equal to over N1 also. And if you have a good eye right off the bat, we can cancel out these N1s, right? And what we're going to want to basically solve for, or what we're going to want to have, is the maximum and minimum on one side, and then all our values that we can plug in on the other. So how I'm going to do that is by first dividing both sides by M max, and then divide by lambda min. So basically, I'm going to have lambda max divided by lambda min is equal to M min plus 1/2 over M. Okay. So at this point, you're going to want to plug in your values, but I think that just for like ease of reference, it'd be better if you got rid of that 1/2 just by multiplying the right side by 2. I think it'll just make the algebra easier. So what we can do then is, say like 2m min plus 1, and then you'll see why I did this in a sec, equals 2m max, right? And that equals, we can now plug in our actual values on that side, which is the 756 nanometers over 432 nanometers. And then your ratio detector should be going off because you can see you can get rid of units here. And then we have 756 over 432. And then if you do the division of that, you'll see it comes up to 1.75, or more helpful, I think, is it in the fraction form where it's actually 7 over 4. So now we have something that is like you're able to solve for what these values would be, right? That being like the m values. All right, so now we have this expression, right, where we know it needs to equal 7 over 4 or 1.75. What can we plug in to make this possible? I think that the fraction makes it easier to see. Oh my God, don't tell me I'm not recording. Oh my gosh, I'm recording. The recording thing went away on my, unless I hovered over it, my bad. Yeah, the fraction actually makes it easier to see that like what we need to plug in, right? So what can we plug in for m min? It'd be 3, right? Because 3 times 2 plus 1 equals 7. And then same thing for m max. What can we plug in for m max? That will be 2. 2 times 2 equals 4. So I'm just going to write, therefore. Sorry, my laptop's about to die, so I'm having this charger here that's making it complicated. So I'm going to say, therefore, these like 3 little dots here. I'm going to say m min needs to be equal to 3, and then m max equals 2. So now I have 2 values that I can use to plug into one of either of these expressions in reality. And from that, I can solve for that d value. So I'm just going to go ahead and solve that. So I'm going to call this like part 1, and then this part 2. Right, part 2. So I'm just going to pick, I'm probably just going to pick the one without the plus 1/2 because it's easier for me to imagine. So 2d equals m max, lambda max, over n1, where we remember that m max equals 2. So m max and this 2 cancel out. So then d essentially just equals that lambda max divided by its index of refraction of alcohol, 1.36. So that comes out to be 756 times 10 to the minus 9 divided by 1.36. Oh, sorry, to the minus 9. And yeah, then you'll be able to solve for what d is equal to. I don't have my calculator out, so I'm not going to do that, but that's your answer. Okay. So yeah, I think that the important thing to remember here is remember we have the 2 equations in the beginning. Remember to express the we know the lambda in air, but we don't know it through this alcohol. So you have to divide both of them by n1. Conveniently, that both cancels out though. And then just, I think solving it as a fraction just makes it easier to see and then easier to plug in. And then that's your d value there. Okay, so that's number homework 9, number 4. I'll do the other view that people asked about now.